Welcome to the Surgibots Podcast, powered by Cruxx.
So there is a race to have the first miniature ultrasonic device on a robot.
I wanted to bring the benefits of ultrasonic devices, which is they're safer, they're faster, they're versatile, they can cut and cauterize without blood loss.
There's no the perfect recipe for how to spin out a company, how to bring your idea to market. That one doesn't exist. There's so many applications of ultrasonics that you don't even know, and where miniaturization could be key to take this to the next level. They are trying to apply surgical concepts into repair of jet engines from inspection ports.
It kind of changed my mindset of what's possible even in a science environment. Ultrasonics will enable finer surgeries for patients. In robotic surgery, allows to translate some procedures that are maybe carried out now in open surgery into robotic surgery.
Before we deep dive into this episode, I wanted to take 30 seconds to introduce you to the sponsors of this season of the podcast, TTP. TTP is a technical consultancy that has a 35-year track record helping companies transform innovative ideas into market-ready products. Their 300-strong team of scientists, engineers, and designers all under one roof can take care of your surgical robotics or imaging technology from a napkin sketch all the way through to early stage commercialization. I was lucky enough to get the invite out to their Cambridge facility. They gave me eyes on a number of the projects they're working on, and not only is the facility state of the art, but the main competitive advantage I see with these guys is their people. A group of incredibly smart, focused and friendly guys who do not shy away from a lofty engineering challenge. If you want to learn more about some of the work they've done or to talk more about a project you have in mind, shoot me a message on LinkedIn or visit their website, ttp.com, to get in touch with one of the team. Hello Nico, and welcome to the Surgibots Podcast.
Hi Henry, thanks so much for having me here today. I'm really excited for this.
So am I. It's a pleasure to have you on. So let's kick off. Let's go into your background. So talk me through how you got here and what you're doing now.
Right, so it's a very nice kind of thing to what I've done in the past. So I come from Italy. I did biomedical engineering at the University of Cagliari in Sardinia, and then I decided that I was done with everything and I wanted a big change in my life. I moved to Scotland to learn English, and at the start I didn't really want to study anymore. I had a very strange relationship with the university. Kind of a hate and love kind of thing. I started working, learned the language, and decided one day that maybe university is for me again, and started a master again in biomedical engineering that I would say changed my life and changed my perception about the uni. I fell in love with science again, and I discovered the world of ultrasonics. After that, due to my final year project, I was invited for an interview in Glasgow, and they effectively presented me with the opportunity to do a PhD. At that time, I didn't even know what a PhD was, but I checked. I was getting paid for it. I was getting paid to do science, which was I was excited mostly at that time, and I did it. And again, that PhD kind of built the blocks of what I'm now. At the final year, I was away in China doing an internship, and I came back because of COVID. And when I came back from COVID, effectively the funding was running out for my project, and I joined the UltraSurge grant, which was looking at the future of ultrasonic instruments. At that moment, instruments were like my passion, and I was looking there. I was thinking, what do I do with them? How do I invent the next instrument? And I had a lot of time to think about, and came up with an idea. There was miniaturization of ultrasonic devices, and then we decided to commercialize it. And then I guess we can go into details later, but I'm happy to.
Absolutely. So let's go back then. So you fell in love with ultrasonics. You said you came across it in your masters. What was it about the ultrasonics that enticed you? And do you have an experience that shaped your love for ultrasonics?
What's really cool about ultrasound in general is the fact that as sound First of all the principle of physics that apply to conventional sound, what you can hear, apply also to ultrasonics. What's really cool is that it's invisible. You can't really hear it. Normal human cannot hear it. And it's all at high frequencies. What's really cool is that you can interact with any tissue, any kind of material with it, and modify it without even touching it. Sometimes you can look into things without physically being inside them. So you have conventional ultrasonic imaging where you can look at things by delivering sound and receiving it back with an echo and analyzing it. But also, when you use the vibration of it, the physical vibration, you can make things vibrate, interact with tissue, and that was really like surprised me. You can penetrate and modify tissues and make operations with it, which is very different.
Very cool. So when did you first come across it? Was it like a module, or did you come across it in the operating room? How did you get into ultrasonics?
So I was really lucky to work in a project with a person called Dr. Mohammad Sadiq, and then he was developing an ultrasonic needle for biopsy. So effectively it's a conventional needle that will go inside the skin, but because it's vibrating with ultrasound, creates less trauma, and there's a lot of patient benefits to it. So it reduces the penetration force, there's no needle deflection, so the procedure doesn't need to be repeated. And what's really cool, it can be seen under another ultrasound probe. So the surgeon or whoever is carrying out the procedure can see the needle in, and it comes out under color Doppler. So you see the color needle, because it's vibrating, so they get captured by the Doppler effect. And then the surgeon can target the surgical point quite accurately. So I was really fascinated. I was tasked with, can you design a new one? And I was like, oh my God, what's this? That's very cool. So I had this big opportunity that changed my life, really.
Epic. And so during the COVID times, you were in China at the time. So it was an experience over there, as I understand, that actually, I guess, changed your direction. So can you talk a bit more about what happened in China and what happened when you came back?
So I think so in China I matured a lot. I think what you are exposed there is another world, but also another world in terms of science. The guys there really work hard beyond the normal boundaries, and everyone is striving to get there first. So there is a lot of competitions, but at the same time it's very collaborative. So it kind of changed my mindset of what's possible even in a science environment. For me, I was involved with the CCAS, which is the Shanghai Institute for Ceramics. And although they're kind of a research institute, they're very commercially focused. So they commercialize the research quite quickly. Everyone is involved. So everyone does his own piece of research. It could be a PhD or a postdoc. But at the same time, they deal with commercial contracts as well. So you've got this duality of the researcher already doing applied research in the real world. And when I came back, I was like, well, okay, I need to do something like this, just because research itself is very exciting. That's what I really like. But seeing also the commercial side of things, it keeps you there. It keeps you like in contact with reality. It's not just maths on paper. It's things that can be useful for the world. So when they've asked me, do you want to join this project, which was looking at the next generation devices for robotic surgery, I was like, oh God, this is actually something real. I get to talk to surgeons, I get to talk to users, and I can see the application of my research really.
Absolutely. And so that brings us nicely on to Nami Surgical. So let's talk about what you guys are developing, but also how that's related to surgical robotics.
So Nami Surgical was founded as a spin-out company from the University of Glasgow by myself and Dr. Rebecca Cleary. So originally, the story of Nami is more falling into things, not in a random way, but just catching the good opportunity quickly. So originally we thought we had something good from the beginning, so we found a way to miniaturize ultrasonic devices. Now, ultrasonic devices for surgery, like ultrasonic scalpels, have got a big constraint. So the dimension of these devices is fixed and can be changed because the frequency at which they operate at depends on the dimensions of the device. And now, conventionally, they are handheld tools. They've got no waveguide, which allows you to transfer the energy from the transducer towards the surgical site. And they're used in laparoscopic surgeries, quite as a, like almost a gold standard instrument. They can cut and cauterize without blood loss. Now, the story of Nami is, how can we make these devices better, or how can we make them fit for robotic surgery? So in robotic surgery, you've got all these instruments that are wristed, so they allow the surgeons to go inside the body, but not just operate in a straight line. They've got wristed joints that allow the surgeons to have 7 degrees of freedom. At the end effector, they perform complicated surgeries. Now, when I started talking to surgeons at the start, they could not use, or they felt there was a limitation in ultrasonic instruments because they could not manipulate them. So I wanted to bring the benefits of ultrasonic devices, which is they're safer, they're faster, they're versatile, they can cut and cauterize without blood loss, into robotic surgery. And to do that, I had to miniaturize ultrasonic devices to dimensions that now allow a transducer to be mounted at the end effector of a wristed robotic joint. So Nami is effectively unlocking the future of ultrasonic devices for robotic surgeries in all surgeries where miniaturization is key.
Okay, epic stuff. So talk to me about, like, traditionally in robotic surgery, what instruments are available right now and what the limitations of the current instrumentations are compared to ultrasonics.
So I'll try to kind of categorize them in a simple way for everyone. So you have, in robotic surgery, you have your endoscope that looks inside the body. That's what the surgeon uses to visualize what's happening inside, and that's a standard instrument. Then you have manipulators, so things that allow you to move tissue around, and they can be standard with no energy or with energy. Now, energy instruments have an extra functionality beyond just manipulating tissue and moving it around. They allow you to deliver energy, and at the moment, electrocautery is the kind of the gold standard that delivers energy, electrical energy, effectively, to the tissue, and it burns, it cuts, it cauterizes as well. Now, you have different energy instruments. You have monopolar instrument or bipolar instruments, so depending on what the surgical task is, the surgeon chooses a set of instruments for that. Ultrasonic, I would say, has the same functionalities as electrocautery. However, it doesn't deliver electrical energy directly to the surgical site, but deliver just vibrations. Now, these vibrations create friction within the tissue, and they allow to cut or perform different cauterization processes. I would say it does enable finer surgery because the dissection margins are more precise, there's less thermal spread, and allow you to perform a lot of finer tasks that are not possible with electrocautery.
Okay, and so what does that really equal then in terms of clinical benefits?
So I think ultrasonics will enable finer surgeries for patients in robotic surgery, allows to translate some procedures that are maybe carried out now in open surgery into robotic surgery, so expand the application of robotic surgery globally, and become the standard everywhere, in every application where there is where tissue preservation is key. So I would say all those specific liver surgeries where you have tumors to be removed, you can increase the percent of healthy tissue around the tumor, for example, so preserve as much healthy tissue as possible. perform finer resections, as well as do all the, I call it blood control, like a blood loss control, so you can cauterize faster tissue and proceed to the next level as well.
Okay. Is that going to then, like with the clinical outcomes, like reduce hospital stay, or is it getting better results from like removal of the tissue? What's kind of the patient benefit mostly?
I think it will allow to expand the application of robotic surgery, so that will come with all the benefits, start with the standard benefits from robotic surgery, so reduce hospital stay, reduce the burden of the healthcare providers and NHS, for example, and improve as well the recovery, the speed of recovery, and this all of this.
Epic. Okay, so what's the engineering challenge with getting the ultrasonics on an end effector? I guess why has this not been done by the traditional robotics companies so far, and what's been the biggest challenge you've had to overcome to actually enable ultrasonics in robotic surgery?
So I think ultrasonic instruments have been around since the 1950s, and everyone has focused before on the delivery of the energy, so delivering tips that allow the vibration to be kind of focused for the specific application. So you've got some major players that have developed these tools, and the transducer itself, which is what converts the electrical energy into useful vibration, kind of the engine if you want, has a fixed dimensional constraint. So normally in soft tissue applications, which is my focus at the moment, bone scalpels vibrate between 30 to 55 kilohertz, 55,000 times per second. And to generate that vibration at a specific frequency, they have to be of a specific dimension, in this case, specific length. So they generate longitudinal waves. And what's really interesting is that I said this at the start, ultrasonics is like sound, so you can compare it to like a bell. So let's say if you've got a bell, you have a big bell, you've got a very low pitch sound coming out of it, and if you have a small bell, you have a high pitch sound. Now that depends on the dimensions of the bell, right? So you can't really change the physics of it. What we've done is that we made a small bell vibrate or emit the sound of a big bell by engineering the kind of the metal structure, so the structure of it. So, and kind of broken the limitations and the constraints of the physical dimensional constraints of ultrasonic devices. Now we can reduce the dimension of a transducer and make it vibrate as a big transducer, not just in terms of vibrational amplitude, if you want, but in terms of actual frequencies and sound coming out from it.
Okay, excellent. So is this the first time this has been developed then, like shrinking it down and using these different materials to create this?
This is the first time it's been done, and as an interest, how Nami was born was by pitching this idea to our kind of professors at the university, which they're from the Center for Medical Industrial Ultrasonics, which is probably the largest ultrasonic group in the world. And they've never seen something like this before. So they were the first one that suggested, oh, maybe we should patent this idea because it's really cool. So
how did you come across that then? So like when you were doing your research, what do you remember the time where you were like, hey, this could actually work? What was the eureka moment where it kind of just flipped and you were like, hey, we might be able to figure this out?
So, right, it was during COVID, so I think I had a lot of time to think about this. I went there into pretty much trial and error as every engineer. Originally I started, so I found the challenge by talking to surgeons. Okay, they were like, can we make a transducer smaller? And then I went back to not the lab, because I couldn't go to the lab because of COVID. I went back to my software and designed a very small transducer, and soon realized, oh, well, if I make it very small, it won't vibrate at the same frequency as the other one. So you can make it as small as you want, really. It's just a manufacturing challenge, but then it won't deliver the energy, it won't deliver that vibration at the frequency that is useful for surgery. So then I really spent weeks thinking, how can I do this? How can I make this device work? So I started looking up metastructures, which I would say there's my idea was, can I make something small vibrate enough to deliver the vibration? But I couldn't find anything online, so this was, oh, no one has done this before. What about if I flip the challenge? Has anyone done the kind of trying to take vibrations down for other reasons? And I found a lot of papers and research on shock absorption and vibration. So people that make floors that instead of propagating the vibration, absorb it. So kind of you enter into this, I call it like a group of islands of different papers. So people try to solve challenges of vibrations, which are a big issue, and for bridges, for anything. And I discovered people working in metastructures. So people that have this special materials, mostly 3D printed at the moment, that when you give them an input, they actually on the other side, you don't feel anything. And it's all like kind of fine engineering of topology and different structures. I was like, what if I flip the concept though? So what I did, it was actually starting from no vibration. What if I apply these structures into ultrasonics? What could happen? And it worked. Surprisingly, it worked. So you can engineer a structure with a small input, kind of change the input into something that is useful. So I applied that concept of metastructures into ultrasonic devices, I would say, for the first time.
That's so cool. And then you presented it. No, it does make sense. So that's really interesting. So when you put that to the university, they were like, hey, we should patent this idea. Talk to me about the journey of actually building the company then. So you sat down with I think Rebecca Shirley is, I think, who you mentioned. You sat down with her and decided to spin out this company. Talk to me about the journey that Nami's been on since then.
Right. So when we first talked to the university, we talked to the innovation services, and they are the one that looked at the opportunity for this idea. So by effectively scanning all the patents that were out there, they were able to identify if there was any previous kind of similar idea or anything. And what came out of that is that they couldn't find anything, so they decided to progress the patent application for Nami Surgical first patent, I would say. Since then I've they recommended to me to apply to this program called iCure, which was funded by Innovate UK, and that's innovation to commercialization of university research. And I was on holiday in the Isle of Skye and decided, well, okay, I'll give it this a shot. I wrote the application, submitted it, and everyone was like, oh, you're never gonna get it. It's a very competitive thing, but I've been lucky enough to be successful with that one. So I jumped on the program without knowing even what that was. We had, I think, around 12 universities all around the UK, everyone with a cool idea, and they made us do market discovery and market research. So in 4 months, I was tasked to talking to over 100 companies in the space of ultrasonics and trying to understand if there was an opportunity for this idea. Like, is it good enough for your sector? I talked to companies in the medical device industries, like big, large giants, as well as someone doing underwater repairs in oil and gas in Aberdeen. So it was a very good spread. And what came out of that is there was a very big appetite for miniaturization of ultrasonic devices for any kind of field. So at the end of the program, I presented the results to Innovate UK, and kind of my first pitch presentation, if you like. And the recommendation was to spin out the company. So they recommended to spin out. So we registered the company in December 2021. After that, I was allowed to apply for a government grant, again, for people that have graduated from the ICURE program. So all the ones that have recommended to spin out a company, they could apply for this program. And I've applied. And again, luckily enough, I was successful. So we had the first kind of funding to progress, and that was £300,000 from Innovate UK to take this technology forward. And that's the moment where Rebecca, which was one of my colleagues at the university, decided to jump on. She jumped on, and I guess that's how Nami started, really. Like, I can go in more details in more recent developments, but that's effectively how it started. We were lucky and to have a good opportunity, and it was perceived that way as well by other people.
I'm interrupting today's episode to bring you a word about one of our sponsors, Fundamental VR. If you go back to season 1, you'll find a great episode with Richard Vincent, CEO of Fundamental, on all the reasons why training in the virtual world can shorten the learning curve and reduce training burden and costs. Improve competency at scale with interactive digital twins of your surgical robot or medical device in a high-fidelity virtual environment. Drive commercial success with Fundamental VR's virtual reality solutions. Just going back to, you were talking about having conversations with like the big multinational medtech companies. So how did those conversations go? Like, how did you approach them as a startup, as someone who doesn't even have a company yet? How do you go and actually get the conversations with those people and knock down those doors?
So I'll say, so first of all, I'll set the scenario for you. This was done during COVID. So normally in market research, you have people picking up the phone, always trying to get to talk to the highest person in the company or whatever. I didn't have really a method. But suddenly all the people that I want, they had a lot of time to talk to me. So I went, so my strategy, I'll tell what worked for me. So I think I had a cool idea. I generally think I'm good with people, and I'm trying to catch their attention. So I went on LinkedIn and started spamming 360 degrees everyone. I would always aim for the higher up. Then if I didn't get a reply within 2 or 3 days, I will go down the road. But you will find that always commercial people will like to talk to you. And then I would target either commercial stuff or engineering stuff, quite low level. But then if I go low level, then slowly I'll climb up. Then I've been working in ultrasonics for let's say, now's the past maybe 8 years. But in those 8 years, even during my PhD and my master, I built up a network, a very valid network, and I leveraged that network to get into multiple connections. Every time I finish a conversation, I would ask them, who can I talk to next? And then people are quite happy to give you an introduction. The introduction makes a difference, is the next step. And then I will pursue, let's say, out of 100 opportunities of conversation, I will go with all of them. I didn't leave anything unturned. So I think you'll never know, even with a conversation that maybe it's not taking you anywhere. At the end, maybe you get a connection to the next one. And then it was all played by ear, but trying to use as much network as possible, really.
And so also, you said that you went to other companies outside, and there's a big appetite for ultrasonic miniaturization outside of just the medtech space. Is there a plan in the future to apply this technology to other specialties? And if so, what are they?
So I think that will be my dream. I think ultrasonics is widely used in the medical field, as we discussed, of course. But then there's a big chunk of ultrasonics is also in underwater acoustics. So sonars, for example, not necessarily for military application, but also for navigation and fish finding, for example, is widely used for in situ repairs. Ultrasonics can be used for welding two materials together. So for the face masks, they were very popular during COVID. They were probably ultrasonic welded. But in situ repairs, you will find that miniaturization is key. You've, for example, you can see I had conversation with, I can't name the company, but people that repair jet engines, okay? So jet engines, imagine how many parts they have got inside, and every time you need to carry out a repair, you need to take them all apart and put them together. So for companies, it's like a huge part of the processes actually taking care of all the taking apart and putting together. So they are trying to apply surgical concepts into repair of jet engines from inspection ports. So imagine you can go into an inspection port, don't take the engine apart, go in and do exactly the same things you're doing in keyhole surgery, but with a wristed ultrasonic tool. So I thought that was mind blowing, and I could not have had a conversation without just, oh, can you introduce me to that person? Can we just talk and brainstorm an idea together? It's brilliant. So there's so many applications of ultrasonics that you don't even know. And where miniaturization could be key to take this to the next level.
Awesome. Cool. I just thought that was quite an interesting point. So you got with you got with Rebecca Shirley, and that's where we kind of stopped the story. You got with her, teamed up. Let's continue from there. So what's happened since then?
So we spun out the company, started to behave like a company, which is very different from working in a research group. So it was evident at the start that we needed some also help, kind of business as usual help, just to know what are the steps. One of the key tasks for us was one was demonstrating the technology. The other one is demonstrating that we have a company that can operate. And the third one was fundraising, because we had this amount of money that was given to us by the grant. But what's next? To go next in medical devices, you need always funding. We need to fundraise. You need investors on your side. So we brought in a CEO, a very experienced CEO at the start that had a kind of a global experience, and they helped us kind of shaping the company, kind of establishing the fundamental blocks, all the things that we have to think about, because we could not just focus on the science, then the rest has to develop as well. So we kind of mature into these roles of being aware of all the things, all the blocks that were needed to get there. So we hired our first employee that was also a master. He did a master project with us, and we decided that it was a good fit for us. He knew the technology, so he jumped on board with us, completely blindfolded. Let's do this adventure together. So we had a couple of goals, as I mentioned before: demonstrate the technology, but make it in a way that is more presentable to a company, because we know that what we had to demonstrate. The second thing was we need to find investors that want to invest in this, because we need a lot of money just to develop the technology forward. And we kind of took it from there. We had a 360 roles in a startup. We decided that the best approach was everyone does his bit, and we kind of contributed together. So we started pitching to investors quite early on. I don't know. If I think about it now, it looks like a long time ago, but it's only a year, probably a year and a half ago. So we kept having those conversations with big companies, trying to understand what they wanted better, refine our product, and we came up with our first MVP.
Amazing. And now you're quite a large team now, aren't you? You've raised that investment, that first seed stage, and now you're a team of, I think, 18, did you say, on our last call?
So we are 15 people now involved with the company. We've got different teams. Yeah, so we managed to raise the investment. It was hard, I'm not going to lie. So for an early stage company, demonstrated you have got a good value proposition, and the opportunity is large, is key. So I was recently in a meeting where it was called Flip the Script. It was done by KPMG. It was one of the best events I've been in. So we had investors on the stage for the first time, and companies were asking questions to investors. But then what came out was really like the biggest revelation of the meeting was investors listened to hundreds of opportunities every single year, and maybe only 3 or 5 of those opportunities will go forward to the investment stage. So you need to have you need to be aware of what you have, but you need to be able to sell it and shape the opportunity for yourself. So you need to have also a very good business model that makes your idea viable in a commercial environment. So for me, it was really like it gave me a lot of confidence just hearing this, because we were successful. So we managed to close the round with local, I would say, investors from Scotland that are very supportive, and we established a very good relationship with them. So I feel like also that they can help me in different phases. Closed the round in April, so we raised £2.5 million. And along with it, Rebecca and I were successful in a biomedical catalyst grant, which is another Innovate UK grant, which we raised with that another £1 million. So overall, we're well funded. That allowed us to, first of all, move away from the university in terms of location. So we now have an office fitted with a machining workshop where we can make our devices, and a very good, very high-tech lab for developing our driving system and the technology factor. We've hired a team for the transducer, so developing the transducer, and a team for developing the driving system, as well as business development people that help us with carrying out the normal activities of a business. So we're now completely independent and diving into this journey.
Excellent. And so you touched on the business model being a very important factor here. So what is your go-to-market looking like? Is it looking like a partnership with the surgical robotics companies, and that's who's going to drive your investment? Or, talk to me about how this is, revenue, not investment. Talk to me about how this is actually going to market.
Yeah, so this was one of the key pieces before investment for us, was deciding what was the best business model to adopt. I'll talk to you like about the maybe original idea was let's develop this medical device and start selling it to everyone. That was the kind of concept idea. But then when we tested that into the market, we soon discovered, well, it can be done. It requires maybe £100 million for the idea to be developed, in terms of setting up factories and staff regulations. There's a lot of things you need to deal with a medical device. And the second thing that emerged was that it was way slower than anything else. So it could be done, but maybe it's a 7 to 10 years journey, and a what cost? A cost of the lots of investment rounds, and that will be delivered later to patients. So we had to rethink, regroup, and kind of talk to companies what could work both for us and for them. So there is a race to have the first miniature ultrasonic device on a robot. So we're in a good position because we got the technology, but how do we deliver this? So it's clear that we will always be an accessory of those surgical robots. And if you look at their model itself, as surgeons will order the instruments for their specific robot, not directly from a third party, but directly from the robot manufacturer. So we have to partner with robot manufacturers to deliver this innovation. So our business model effectively changed that. So we've got technology that can realistically be applied everywhere in any robotic platform. It's no robotic platform specific, can be adapted and shaped for them in terms of interfacing. So we kind of want to embark in kind of feasibility studies and R&D project with robotic companies to shape the technology for them, and then enter a future commercial phase where we either license the technology or we can find a OEM that manufacture the technology for them, but they'll be the sellers of the technology. We kind of license out what we have.
Brilliant. So let's dive into what's next for Nami Surgical.
Nami, now we've got a new formed team, which is super excited to be on board with this technology. We are working towards a feasibility study, and I'll explain this better. So we've got a device, which is the ultrasonic transducer, including the blade, if you want, that we've proven it works. It does the job of cutting and cauterizing vessels up to 7 millimeter in diameter. It can cut different tissues. Now what we're working on is kind of a platform concept. So the transducer is, let's say, it's ready to be modified accordingly to the requirement of our our commercial partners. The driving system is the kind of what drives the device, and that's in very early stage, but we're developing it. So in terms of proving the feasibility, we will prove the feasibility of the driving system, which controls the transducer. And that's also a platform that can be applied to any robotic, on any surgical robots, really. There are companies that have ultrasonic experience and companies that don't have any ultrasonics in-house. So we will be able to expand our product offering to the transducer, to people that have got ultrasonic experience, and transducer plus driver to who doesn't have it effectively. A big part of the company is now to establish ISO 13485, because we are pitching ourselves as a medical device company, but also we need to establish the framework to work in it. So the team is working really hard to establish all those protocols and procedures. We're establishing our QMS, and a good part of it is that we have a machining workshop, specialized machining workshop for ultrasonic devices. So we are refining all the kind of manufacturing processes for our transducers that we're bringing in-house for the first time. So there's a lot of changes, a lot of team adaptations at the moment. And next we are ready to go out there and propose our technology to companies which we are keeping warm at the moment.
Excellent. So moving towards commercialization, then that's the next step for you guys.
Yes. So we plan to have our market entry by 2027. So we're trying to expedite that as quick as possible. But that depends really also on the partner and how much the commercial partnership and what that will bring on the table for us. We've got the same dream, I think, together with the partners to bring this to market as quick as possible.
Okay, excellent. So I want to take it to getting your advice really for there's a ton of people who listen to this podcast. Some of them are very experienced and been in the field a long time, but some of them are like masters and PhD students who might want to do a similar thing to you and spin this technology out into a company. But what advice do you have for those people? What have you learned across your journey? What advice would you give? And how would you maybe do things differently if you were to do it again?
Right. So based on my experience, and I would say this is really important because there's the perfect recipe for how to spin out a company, how to bring your idea to market. That one doesn't exist. Even the steps, sometimes they mix up together, depends on where you're based. So I see, like if you look at the Silicon Valley model or even the London model, if you want, you have a lot of investors, a lot of people that are ready to give you money to bring your idea. In other parts of the world, that's more challenging. People don't give you money that easy, or you go investors that are more financially focused. So first of all, if you have got an idea, don't immediately jump on, I want to spin out a company, because that it requires some more further thought. So I think the journey I went in made me mature into, okay, I want to do this, and I think the opportunity is real, and I really believe in my technology. So you need to analyze first and listen a lot. When you talk about your idea, listen what other people have to tell you and what other people tell you. There is a point where at the beginning, I think, when people realize that you've got something big, when you talk to them, they want to help, and that help is genuine, because you listen. That's how I brought my idea to market. So if you listen to my podcast today, you'll see my journey. But then that maybe would be different for another type of product. So medical devices they've got very strange way to be commercialized. And some companies will maybe embed you from early stage and they'll take you in and then they'll do all their bets. But then if you do them by yourself, like we do, there's no clear path. So there is a first phase where you need to listen. I think that's really important, and talk to your potential customers, identify what those customers are. And if you get a lot of positive feedback, then there is maybe a chance that your idea is good to be commercialized. The second part is you made them aware that you've got something. At some point, everyone wants to help you, and you need to filter the help in what works for you. So you probably at the start don't need 300 people to make this happen. It could be yourself and your co-founder, and then you kind of need to work the bits, and you need to save as much money as possible and make all the things happen. So the second thing is you'll be advised that you're not experienced enough at the start, which is fair enough. That's true. People don't have commercial experience, especially if you come from an engineering background. However, I think if you've got the rationale enough for understanding that your idea can be commercialized, you can mature into any role you want. So don't let people tell you that you need this advisor or this consultant to make something happen. Just try to understand it yourself first and have your own opinion, because your opinion matters as well. At the end of the day, you'll be the founder and you'll be carrying out all those tasks, and you'll be the one that is going out there try to find money for it. Third thing is the investors. Investors are key. Sometimes you've got a lot of investors who want to give you the money, but then are they the best fit for you? You need to find the right ones that are also supportive of what you want to do. They've got also I call it kind of an impact strategy as well. So just don't bring ideas to market just because they're profitable, but bring ideas to market that have an impact, a society impact. So bring benefits as well. Because at the end of the day, it's your company. You don't want to be labeled as someone, oh, well, this company is just profitable. I think that just works for me. I want to bring patient benefits. I want to do this together with investors that join that. And then just be sharp. There's a lot of sharks out there that look for opportunities and they can steal your technology. So the second bit is make sure you've got your IP well covered before exposing yourself. We had a year of stealth mode that actually helped us a lot. You get people, oh, just talk to that one. That's a good opportunity. You can close a deal very quickly early stage, but then is that beneficial later on? I don't know. You need to find out the best way, and I can't advise on that, but you need to be able to be sharp.
Okay, understood. So do you feel like in that early stage then there was people trying to take advantage of the opportunity, and like how do you, I guess that IP piece, how do you get that locked off at an early stage? How do you make sure you are protected? How do you, I know you said you can't give too much advice on how to do that, but how do you look out for those sharks when you're having so many conversations trying to do the feasibility and look at the product?
So I think it's an art, because on one side, you're having a conversation with a big company. You need to build their appetite for you to keep talking to you. But at the same time, you cannot share enough details about the technology, because you can share too many details. They've got hundreds of engineers. They can turn this the next day if they wanted. So what we did, I think what helped Nami was that the main core IP was filed before spinning out the company. So we kind of had that covered. So it doesn't give you a full, because the patent is not granted, but doesn't give you full immunity, but you're covered enough that what you need to be careful what you share in every conversation. So the support from the university, I think, was key, because they were able to fund that part of the project. But it's an art, I think, Harry. I feel like building appetite is that you need to do research on those companies you talk to, and then see what they're working on, how they pitch themselves against the competitors, and then try to steer every time the conversations into something that they've got an appetite for already, and then your technology can solve that problem. So it's more of like you need to propose yourself as I can help you doing this if we work together, and share as less as possible, but enough to build that relationship.
Cool. So if people want to reach out to you, because there's surgical robotics companies who listen to this, there's researchers, there's academics, there's investors, what's the best way to reach you, Nico?
So I'm quite responsive on LinkedIn, unless someone is a consultant or something else. I try to filter out those messages. Apologies, but normally I'll look all the messages on LinkedIn. So reach out, please, on Nico Fenu. You'll find me quite easily. Otherwise, by email, nico.fenu, Fenu at namisurgical.com. Please feel free to send me an email. I'll be able to respond. And we are open for conversation, so please reach out.
Excellent. And so, do you have any final comments before we leave this podcast?
So I think what I want to say is like Nami Surgical was born out of passion of both ultrasonics, but also kind of taking an idea from the lab to the real world scenario. And I think every company that is working in the surgical space, and particularly in robotics now, have got like a passion, like a fire inside to deliver innovation, deliver technology quick, because it's so vibrant and the environment is more collaborative than what we think. Although it's a race, everyone is like there. So it's kind of like an exciting time to be pursuing an opportunity in surgical robotics. So I really appreciate also this podcast to have this like opportunity to be kind of exposed to the whole world. Because thank you so much, Henry.
No worries at all. It's been a pleasure learning about your background and your story. I've had a lot of fun today, so thank you very much for joining me.